in this video we're going to look at the identities for tangent, cotangent, secant, and cosecant. Now if you remember the tangent curve, we have this kind of S-shaped curve that again repeats. And some helpful formulas that go along with that: tangent of negative a is equal to negative tangent of a, and you can see here, for instance, if you go to 1, if you go back down here to negative 1, you can see how those have negative amplitude of each other. Those are the same magnitude, essentially about 1.5, but they are opposite in sign. The addition and subtraction formulas for tangent are as follows. Tangent of a plus b is tangent of a plus b over 1 minus tangent of a tangent of b, and tangent of a minus b is tangent of a minus tangent of b over 1 plus tangent of a tangent of b. So let's look at using those to prove some things and simplify some things. So if we want to prove that the tangent of theta is equal to tangent of theta plus 45 degrees is equal to this fraction, again, we've got addition here, so we probably want to use this formula right here. We've got the tangent of theta plus the tangent of the second angle, 45 degrees, and we're using degrees here, that's fine, over 1 minus the tangent of the first angle times the tangent of the second angle. So again, first and second angle. Again, we have some things that we can simplify here. We know that the tangent of 45 degrees is 1, so we end up with the tangent of theta plus 1 over 1 minus tangent of theta times 1. And if you rearrange these, which you can do because it's addition is commutative, subtraction is not, but addition is commutative, we get 1 plus the tangent of theta over 1 minus the tangent of theta. And again, 1 times tangent is just tangent. We didn't have to rearrange the order. We get to what we wanted. This next one is kind of going back to what we had before, going back to those identities: cosecant theta, tan theta. Again, remembering the identity for cosecant. Cosecant is 1 over the sine of theta. Tangent is sine of theta over the cosine of theta. Again, we can simplify sine divided by sine is 1, and we're left with 1 over cosine theta, which is secant theta. So this is just kind of a recall of our lesson from 13.1. Look at a few other examples here. Whenever it says to simplify, that means to use what we had before. In this case, we've got that fraction. We actually want to go backwards to the addition and subtraction formula. And we want to do that because we've got a 4 theta and a 5 theta, which could actually be combined. So we have tangent of 4 theta minus tangent of 5 theta. That looks a lot like tangent of theta minus phi. And again, the denominator works out too as well. 1 plus tangent 4 theta, tangent 5 theta. So take a good look at your equation sheet. So we can rewrite this as the tangent of 4 theta minus 5 theta, again using that identity that we have, and that ends up being tangent of negative theta. We don't like negatives inside if we don't have to, and we have that identity that says that this is really negative tangent of theta. So this would be the most simple version of this function. Let's also look at cotangent, secant, and cosecant. Cotangent of negative angle is negative cotangent of the angle, which makes sense. It's going to match up with tangent. Secant of the negative angle is equal to secant of the angle, and again, this is going to match up with cosine. And finally, cosecant of negative angle is negative cosecant of the angle, and again, that's going to match up with sine. So again, let's go through and see if we can prove or simplify some of these things. Tangent of theta plus 270, we're going to use that addition formula for tangent, so we end up with the tangent of the first angle plus the tangent of the second angle over 1 minus the tangent of the first angle and the tangent of the second angle. And when we go through and do some simplification, we see that we run into an issue. The tangent of 270 is undefined. So this isn't going to work. again, as you recall, I did say that sometimes we can kind of get led on a wild goose chase with some of these. What we pick doesn't work, and again, this doesn't work because tangent of 270 is undefined. So I'm going to move this over a little bit to make sure we have enough room. Okay, that didn't work. So what can we do instead? Take a second here to think if you can come up with any other thing that will help. Hopefully you came up with the fact that tangent is sine over cosine. Sine and cosine are always defined, so this works. We can change this to the sine of theta plus 270 over the cosine of theta plus 270, and hopefully this will get us in a better direction. Again, going to the addition formula for sine, we know that this is going to be sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And for cosine, we're looking at the addition formula, cosine of the first angle, cosine of the second angle, minus sine of the first angle, cosine of the second angle. And again, we know some things about cosine and sine at 270, or 3 pi over 2, whichever way you want to look at it. Cosine of 270 is going to be 0, and sine of 270 is going to be -1. So this ends up simplifying, because again, this whole first term then is going to be 0. We just end up with cosine of theta times -1, and in the denominator we've got negative out here. Again, this whole first piece is 0. You can write that if you want to, times the sine times -1. Again, we can go through and simplify a little bit. We got a negative cosine of theta, negative is positive sine. And we know that cosine over sine is cotangent. It's negative just like we needed it to be. And this is how we would simplify that one. So again, sometimes we go in the wrong direction, and that's okay. We need to make sure that there are other alternatives. Okay, I want you guys to pause the video here and try the next example. So again, for this one, we'd have to rewrite it. We don't have any addition subtraction formulas for secant and cosecant because we can always just convert them to sine and cosine. So secant is 1 over cosine. Again, we can use the subtraction formula there. We know cosine and sine for pi over 2, so we can simplify, and we end up with cosecant of x. Another example here, cosecant of pi over theta. Again, that's just going to be 1 over the sine of pi minus theta. So subtraction formula for sine says that we've got sine of the first angle times cosine of the second angle minus cosine of the first angle and sine of the second angle. So in this case, again, we know sine and cosine of pi. Sine of pi is 0, cosine of pi is -1. So we just end up with 1 over, again, we've got 0 here times cosine, so that's just going to be 0. And then we've got minus a -1 times sine of theta, so that's just going to end up being positive sine of theta. So we can simplify that to be simply cosecant of theta. Again, very similar to what we had up above. Few more examples as far as simplifying. Again, we can always go backwards with our formulas. It's not always going from addition and subtraction. Sometimes we want to go backwards from the kind of more awkward formula back to the addition and subtraction so we can combine some things. Sine of 4c times cosine of c minus cosine of 4c sine of c. You should look at your formula sheet and you should see that this one is sine of 4c minus c. Again, take a look at your sheet just to make sure you've got sine of the first, cosine of the second, minus cosine of the first, sine of the second. Again, 4c minus c we can simplify, and that just ends up being sine of 3c. So pause the video here and see if you can try example 29. So you should have found that this one simplifies down to cosine of 4 theta. few more examples here. If we want to simplify sine of a plus b times cosine of b plus cosine of a plus b times sine of b, again, kind of ignore the a plus b there for a minute, and just think of this as being an angle. So sine of angle, cosine of angle, plus, so that's starting to look like sine of an angle plus an angle, because this is the first angle and this is the second angle. So we can simplify this into sine of a plus b, because we've got that second b. And we could simplify that to be sine of a plus 2b. And that's really the simplest this is going to get. So one last example here. Given that sine of theta is 8/17, again, we had this before, and cosine of theta is negative, so this is the same type of problem we were looking at before. We've got this triangle back here, we've got a height of 8, a hypotenuse of 17, and then an x value of -15. This case we want to find the tangent of theta. So again, theta is here. So tangent of theta is going to be opposite over adjacent, so this is going to be 8 over -15, and we usually like to either bring that out front or up top, that negative sign. Tangent of theta plus pi, so now we're going to go to our formulas. So tangent of theta plus another angle is going to be tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first angle times tangent of the second angle. And we can simplify a little bit. We know what tangent of pi is. Tangent of pi is 0. That's where we kind of start with our second cycle there. So now all we have left up top is tangent. And in the denominator, all we have left is 1, because again, this tangent of theta is times 0. So that's really just tangent of theta, which we already found to be -8/15. So I want you to pause the video here and try the last example. So again, with this one, if you started off trying to just use the addition and subtraction formulas, you find that you end up with some undefined stuff, so you have to rewrite it as sine and cosine. Again, we can go through and simplify. We end up with cosine over negative sine, which is really negative cotangent, and negative cotangent is the reciprocal of negative tangent. So you can just plug in the reciprocal here as -15/8, and then it was negative out front, so we end up with a +15/8. Again, you could have plugged in cosine and sine here if you wanted to. Multiplied by the reciprocal, you'd end up with the same number.